All right, so in the last video, we saw Avogadro's law. You can kind of test it out with this little PHET simulation here. For example, I have some particles of gas floating around in here, moving around, hitting the walls. I'm going to choose to set the pressure as constant, and I'm going to add some more moles of gas using this pump here. And I want you to notice, so we set our pressure's constant, temperature shouldn't change either. I'm going to add some moles of gas, and you can predict what's going to happen to the container. Notice our volume has increased as I add moles of gas in order for my pressure to stay the same. So I have constant pressure there. As I increase the volume, as I increase the moles of gas, my volume increased. I could take out some moles of gas as well. And notice as I'm taking out moles of gas, my volume will decrease. So I can do that. So when you decrease moles, volume goes down. When you increase moles, volume goes up. And again, we can take some out, and our volume will start to decrease as we let some of the gas particles escape. And so that's just a little visual animation of Avogadro's law in practice. Now what we're going to do is we're going to take a look at the molar volume as it relates to Avogadro's law. So let's go to our slide deck here. See what the molar volume is all about. So scientists have come up with two numbers that make it easy for us to do some calculations. They found that at STP, remember STP, we can go back here, STP, 273.15 Kelvin and 101.325. So we have 101.325 kPa, and then we have 273.15 Kelvin for STP. And that's also in your data tables. And the SATP is 25 degrees Celsius, or 298.15 Kelvin, and 100 kPa for the pressure. So it's important to remember that because your molar volume will differ depending on what conditions you're at. So it was found that if you're at STP, your molar volume is 22.4 liters. So what does that mean? The molar volume just means the volume that 1 mole of gas occupies at a specific temperature and pressure. So at STP, 1 mole of gas occupies 22.4 liters. At SATP, 1 mole of gas occupies 24.8 liters. So if we look at these balloons here, they're all at STP. They're all at STP. For each of these gases, we fill them up with 1 mole of H2, 1 mole of O2, 1 mole of argon, 1 mole of Cl2. They have different masses because they have different molar masses, but the point is that because they're all 1 mole at STP, the volume they take up is 22.4 liters. So it doesn't matter which gas it is, because it's 1 mole at STP, it's 22.4 liters. If it was SATP instead, these would have expanded to 24.8 liters instead. This is for 1 mole of the gas that you're studying. So let's see how we can use knowledge of the molar volumes to solve some problems. All right, so we have our molar volumes given to us. Here's another image just to go over. So we have our 1 mole of our different substances, helium, xenon, and CH4 at STP, and they'll all occupy 22.4 liters. And again, that's at a specific temperature and pressure, right? It's specific to that. So let's do our example here. A party balloon has 2.3 moles of helium in it at STP. What is the volume of the balloon? All right, so we said the condition was given to us, STP. So we have 2.3 moles of helium gas. Now at STP, if we had 1 mole of helium gas, it would occupy 22.4 liters, because that's my molar volume, 22.4 liters. In other words, I can pretend like my N1 is 1 mole and my V1 is 22.4 liters. My N2 is 2.3 moles, and I want to find my V2. So I'm still using Avogadro's law. It's just that because I told you STP here, I'm telling you your N1 is 1 mole and your V1 is 22.4 moles. And it's proportional. So if I double the number of moles, I should have roughly double the volume. A little bit more than double because it's 2.3. So we know that our V1 over N1 is equal to V2 over N2. We therefore know that V2 is going to be equal to V1 times N2 over N1. And that's going to give us 22.4 liters times 2.3 moles over the N1, which was 1 mole. Cross moles out, and we get 22.4 times 2.3, approximately 51.52 liters, because we're left with liters in the end. And it makes sense. It's double and then 0.3, so that makes sense roughly. We do need to round this to 2 sig figs because we have 2 sig figs in the problem here. So that's about 52 liters. So we can go and verify if we're on the right track with that. So let's go see if our answers are good. 52 liters is what it would expand to if we added more moles of gas. And that makes sense because we have more moles of gas at that point. So let's try our next problem out. A sample of nitrogen gas at SATP has a mass of 44 grams. What volume does this mass occupy? So remember, this is at SATP now. SATP. And we said that at SATP, 1 mole of gas would be 24.8 liters. That's our molar volume at SATP, 24.8 liters per mole. So you can think of this almost like your, again, N1 is 1 mole, and your V1 is 24.8 liters. Now, we're looking for a new volume. If we have more moles of gas, we have 44 grams. Well, we're assuming this is more moles. I don't know. It could be less, but we have 44 grams of nitrogen gas. So remember that the N2 is the mass over the molar mass, which is the 44 grams over the molar mass of nitrogen gas. Be careful here. Nitrogen gas is N2. So the molar mass is 14.01 times 2, which is 28.02 grams per mole. Cross out the grams. We get 44 divided by 28.02. And that's about 1.57030694 moles. So this should be a greater volume than 24.8, right? Because it's you're putting more moles in there than 1 mole. So we're going to go ahead and solve for this. So we're looking for V2, just as we did in our previous question. V2 is equal to V1 times N2 over N1, which is the 24.8 liters, multiplied by our N2, which is 1.57 moles. And I have all the digits in my calculator. Divided by the N1, which was 1 mole. Cross out moles, and you're left with your liters. So times 24.8. And you get about 38.94361171 liters, which is approximately, to 2 sig figs, 39 liters. And that makes sense. Our volume would have gone up since you didn't quite double, so it's not double the amount. You did 1.5 more, so, or a half more than what it was before, half more than the mole from before. So that gives us 39 liters. Let's just take a look to see if we are on the right track with that. So it looks like, yes, 39 liters, correct number of sig figs there as well. So this was just Avogadro's law with some specific volumes given to us for specific temperatures and pressures. So we just equated, we had V1 as N1 as our initial values that you would have at STP or SATP. That's our definition of the molar volumes provided to us. And then we could just isolate for V2 afterwards. These questions can really specifically be done only at STP and SATP. So we really have to tell you at SATP or at STP in order to get this done properly. But the thing is, we're not always at STP, we're not always at SATP, so there must be some other way to figure out number of moles or volume, and there is another formula that you can use later on that we'll learn about in the next few lessons that allow you to go at different conditions other than just the STP and SATP. So remember, this is based on molar volume. Molar volume of our substance. If you go back to your slide deck, you're going to see that there are some optional extension lab activities you can do. So this is a molar volume lab where you can figure out the molar volume of a substance. Or you could demonstrate the molar volume activity using some formulas and going through this procedure here. So it's a great little extension video to watch to see what it looks like in the actual lab. If you look at your slide, you'll also see that there's other techniques that you can do here. So for example, if you wanted to find the new volume, you could just take your number of moles and multiply it by the molar volume, so 24.8 liters per mole, and that would give you your answer as well. So you don't have to do the whole V1 over N1 is equal to V2 over N2. You could just take your new number of moles and multiply it by the molar volume, because the idea is you have 24.8 liters per mole. And so you can just take your 1.57 moles times 24.8 liters over 1 mole, cross moles out, and you're left with liters. You could have done the same thing over here. 2.3 moles times 22.4 liters per 1 mole, and that's 52 liters. So you can simply multiply your number of moles by the molar volume that you know, providing it's STP or SATP, and that gives you your answer as well. So I did a long way. I just kind of showed you where this was coming from. It's coming from the idea that you're increasing the number of moles from the 1 mole to the, 2.3 moles, and that increases your volume just like we saw for Avogadro's law. But in reality, you can just multiply your new number of moles by your molar volume, and you get the same answer in the end because it crosses out. So just to show you quickly, you could do 2.3 moles times 22.4 liters per mole, cancel out the moles there, and then you get your final answer, which is rounded to the 52 liters there. And that works out for both situations. So that concludes our Avogadro's law. In the next video, we're going to take a look at a few other formulas and laws.